Hey everybody, good to see you. I'm glad you're watching this video. Not sure what day you're watching this on or what time of the day you're watching this on, but I'm glad you're watching this video. So this is a video that's going to be talking about the Triangle Inequality Theorem. Okay, it tells us two things already. We're going to be dealing with triangles and we're going to be dealing with inequalities. And theorem is just a fancy word for rule. Okay, so just like in school, we follow rules. This is kind of the same thing. So this theorem states that in order for a triangle to be possible, the two short sides added together must be greater than the longest side. So there's a couple of things that this rule tells us. Obviously with triangles, we're talking about three sides. So first things first, it wants us to identify the two short sides, okay? And then it gives us actually an operation, okay? We're adding together, so we're going to be using addition. The inequality part comes from where it says greater than. So we're going to be using the greater than symbol. Okay, so we're going to be working through a couple of examples together to show you how to write the inequality and how to determine whether a triangle is possible or not given the side lengths. Okay, so example number 1. The question asks us, if given the side lengths 4 centimeters, 2 centimeters, and 5 centimeters, is this triangle possible? So first things first, we need to identify which two sides are the shortest. And in this case, we have 4 centimeters and we have 2 centimeters. And just like the theorem states, we're going to add those two short sides together. So 4 centimeters plus 2 centimeters. And going back to the theorem, it talks about greater than. So that's our inequality symbol, with the greater than symbol, and then the third side, which is 5 centimeters. And then from this point on, all you have to do is do the addition. 4 plus 2 is 6 centimeters. We keep the inequality symbol, the greater than, and then we keep 5 centimeters. So if you read this statement, the statement says 6 centimeters is greater than 5 centimeters. And hopefully, okay, you know that that is true. And if it is true, therefore the triangle, yes, is possible. Okay? Okay, we're going to move on to example number 2. Okay, so in example number 2, I've given you an actual diagram of a triangle. I've labeled the side lengths 2 inches, 4 inches, and 7 inches. And again, the question is asking, is this a possible triangle? So first things first, we need to identify the two short sides. So we have 2 inches and we have 4 inches. Okay, so those are the two short sides. Then we're just going to write our inequality. 2 inches plus 4 inches. Again, we're adding the two short sides. Must be greater than the longest side. Okay, and then if we do the math, 2 inches plus 4 inches is 6 inches. We keep the greater than symbol. And we have 7 inches. So if you read this inequality, it says 6 inches is greater than 7 inches. Is that true? Hopefully you answered no, this is not true. And if this inequality is not true, then this triangle is not possible. Okay, so moving on to example number 3. Okay, so example 3 is another diagram. We're given a triangle. The side lengths are 7 millimeters, 7 millimeters, and 3 millimeters. And again, the question is this a possible triangle? So we have two sides that are the same length. And if you remember from last year, that means that this is an isosceles triangle. Okay, but our theorem states that we need to pick the two short sides. And in this case, the lengths are the same. So you need to just pick one of the 7s and to add to the 3, which is the other short side, in order to write the inequality. So I'm going to pick this 3 millimeters and this 7. So my inequality that I'm going to write is 7 millimeters plus 3 millimeters is greater than the other, the third side, which is 7 millimeters. Okay, so then we're just going to add the two short sides together, 7 millimeters and 3 millimeters. We get 10 millimeters is greater than 7 millimeters. And again, ask yourself, is this statement true? Yes, this statement is true. And if it is true, therefore the triangle is possible. So yes, this triangle is possible. Okay, moving on to example number 4. Okay, last example, example number 4. If given the side lengths 9 meters, 5 meters, and 4 meters, is this a possible triangle? So again, step 1, identify the two short sides. So we have 5 meters and we have 4 meters. So we're going to plug those into our inequality. 4 meters. And again, guys, this isn't actually important. The units are important. So if you notice, every time I'm writing my inequality, I am keeping the actual units. So 4 meters plus 5 meters. Again, the symbol is greater than, and the third side is 9 meters. Okay, so then we're just going to add the two short sides. 4 plus 5 is 9. And again, they're both meters, is greater than 9 meters. So again, when we read this statement, this says 9 meters is greater than 9 meters. Is this statement true? Okay. Hopefully you said no, this is not true. Again, 9 is not greater than 9. This symbol is not a greater than or equal to. It has to be greater than. And in this case, they are equal. They are the same. So this statement is not true. Okay. And therefore, since the statement is not true, this is not possible, okay? So this cannot be a triangle, okay? So hopefully this video helped you out and clarified any questions or concerns that you might have had, or it might have justified that you were doing it right. So I'm gonna put an activity in there with a couple more practice problems for you, and hopefully you and your family are doing well, and look forward to making more videos and sharing things with you. Have a great day.